Hello, this set of notes is about microwave spectroscopy. As always, there's a set of notes in Schoology that you can use, or you're welcome to take your own. All right, so we've talked about different kinds of molecular motions a little bit so far this trimester. So in order to understand microwave spectroscopy, we have to understand different kinds of molecular motions. So the very first kind of molecular motion that we have is a translational motion. And this would essentially be, we have a molecule, right, and it's moving from one place to another place, okay? So entire molecules moving to a new location in space. Okay, second kind of molecular motion are vibrational. These are the ones that we learned about when we talked about infrared spectroscopy, right? These are vibrations where the arms of the molecule are going in and out, back and forth, bending, stretching, those kinds of things. And then a third kind of molecular motion that's possible is the rotation of a molecule about an axis or rotation around, and this should say sigma bonds. It didn't come through on your on the PDF that I put into this set of notes here. All right. So rotation here is where you have the molecule actually rotating about an axis. You could also have it as part of a larger molecule, like maybe we have a benzene ring, and then up here we have a molecule. You could rotate around this axis as well, and so that piece would be rotating. So if we think about this, then the question is, what state of matter would something need to be in to be able to allow rotational motion? Well, hopefully without thinking about it too hard, you can go, well, it's got to be in a gas state, right? It's got to be able to freely move or pivot around without intermolecular forces hindering that rotation. So as we get to talk about microwave spectroscopy, we know that microwave spectroscopy is going to involve rotation. So that means we've got to have things in the gas state. So, rotational or microwave spectroscopy is done in the gas state because that's where the most free rotation is possible. On Monday, I will show you, or in our next session together, I will show you what that rotation kind of looks like with some actual individual molecules. Okay, but how do you get parts of molecules to rotate? Well, you bombard them with microwave radiation. It induces rotation in the molecules and parts of molecules that have single or sigma bonds. All right. So based on how much energy gets absorbed when these molecules get spun and starting spinning around, we can figure out how fast they are spinning. And if we can figure out how fast they're spinning, we can understand their inertia and their momentum. Well, inertia and momentum are directly related to mass. So we start to understand what are the masses of these things that are rotating about. And if we can understand the masses and we know the chemical compositions, at least of what kind of elements are in it, we can start to put this together with all of the other kind of spectroscopy that we've figured out, and we can actually figure out some specifics about the structure of the molecule. What's attached to what? What kind of bonds there are? Is a particular atom attached here, or is it attached there on our molecule? So microwave spectroscopy allows us to do that. Okay. When we do microwave spectroscopy, we get a readout that looks like this. It's not an expectation of this course that you understand how to read such a microwave spectroscopy. But what you do need to know for this course is microwaves induce rotation, and from that rotation, we can figure out masses and specific parts of our structure of our molecule. That's it.